Hello group. Today's video is going to be on uh, setting up Cyril for those that use Cyril, and I know there's a few on the group, to take advantage of the local star catalogs, Astrometry.net server, and StarNet++, and how you have to download these items and where to download them from. And then you have to point to those locations on your system so that Cyril can take advantage of it. And then I'll show you how they work. So the first thing we'll do is go to a browser and go to the Cyril website. You want to go to Docs, Online Docs, Astrometry, then click Next, and then scroll down till you get to, excuse me, this InServe link. And what you want to do is click on this, and this takes you to the astrometry.net plate solver for Windows. And this is the download here. You want to download it and then run it. And you just kind of follow along with the requesters. And when it's all done, it will then ask you to download the indexes. And in my case, I have a lot of scopes. And I just downloaded all the indexes. It wasn't that bad. So for me, it's easier just to get them all. Then I don't have to mess around. If you only have one scope and you know all the particulars about that scope, then you can just download the index that you need. But you're going to have to get the narrowest field of view and the widest field of view to make this work. So if you have one scope, I would get one below and one above. So you would have three indexes. Excuse me. Then when that's done, we want to go back to the docs, and I'm going to type in StarNet. Sorry, let's spell plus. And we want to do the star removal, and then this is, oh, oops, I don't want this one, sorry. I want the newest one. And in this particular case, I just used the Mac link, and that takes you to the news site, and then you go to downloads. And you want to get the CLI version, the command line version. So for Windows, it's this one here. And you would download this. And when you get it on your computer, you would extract it and then install it. For the final one, we have to open up Cyril. We're going to go to the hamburger, go to Preferences. There it is. And then click on Astrometry. And we want to get the local star catalogs, and you want to click on the More Info, and that's going to take you to the freeastro.org website. And right here where it says download, we want to get the slower direct download links, which is this one. The other links are if you're using BitTorrent, and I'm not a big fan of BitTorrent because I don't like people digging around in my machines. So you want to get this, and this one. Anything with an XZ on the end. When you have those on your system, then we need to go to the Windows Store. Which is right here. It's the little bag with the Windows logo on it. does Windows Store. Open it up, and when it opens, you want to type in 7-zip. And we want this one here, 7-zip for Windows. And the reason why we want that is it will unpack these XZ files. And this is the only reason we're getting this, so that we can unpack these XZ files. When you have that done, you want to put the 4 folders that have the databases. So in my case, it's this one, this one, this one, and this one. And you want to put them in the serial, so it will be C, program files, serial, share, local. And I created a folder in here called KStar. And you'll see that the 4 databases are now in this folder, in the serial folder. We're going to go, and I want to show you where the astrometry.net server goes, and that's in the programs x86, and it's right here. This is important because we're going to have to point to this folder. And for the StarNet++, it puts it in the C programs files, and we're going to have to point to this folder because we want to get to this, the executable. So with that out of the way, we now know where everything is. We're going to go back into serial, astrometry, and we're going to point to these databases. So I've already done that, but I'll do one just to show you. So we want to go to C, program files, serial, share, local, KStar, and we need the name star database. We click on this, say open, and it loads that pointer here. And you would do that for the other 3. And then once you've got that done, we go down to the bottom, and we have to point to where the astrometry.net local server is. And you would do that by going to C, oops, sorry. I've already done this, so other is what we want. Program files, we want actually the x86, then we want to click on this. We just want to select the folder, and you'll see that it puts it in here. Then we want to go to miscellaneous and point to the StarNet++ folder. And that's in my case, it's on the C program files, StarNet CLI 2 folder, and you'd have to go into the folder and then find the StarNet++.exe and select it, and you're done. Then you apply it, and once it's applied, what we can then do is really speed up what happens in serial, because we're no longer looking out to the internet for stuff. In particular, the star catalogs, the astrometry plate solve info, and the StarNet++, even though serial doesn't have it integrated, we still have to point to it so that serial knows where to get the executable file to start doing what it needs to do. So the first thing I want to show is we will load an image that's a TIFF file that has lost all the information about what the file is. And now I want to plate solve this. it says it's already been plate solved. That's not good. Let me get another image. I probably don't have any images on here. Let me throw one in. Well, I can still show you. So what I will do is I want to go into console mode just to show you that when we do the plate solve, it will find it. We go to info, image plate solver. We want to make sure that we use the local astrometry.net solver. That's important because it won't go out to the web. I want to downsample because my images are big, really big. And this is Bernard 33. We can see that it's the horse head, so I will say okay. And it is now solving the image. And it says that it's been solved, and it didn't take that long to solve it, which is good. Now, if there was no information on this date image, it might take a little bit longer, but it will still solve the data. So that's how you would solve an image that you do not have any data for. And you want to use the local astrometry.net plate solver. Next, we're going to open up a FITS file. I'll auto stretch it. And I want to make sure that I'm in perspective. I want to preserve the aspect ratio. So I'm going to do something like this. And I'm going to be aggressive with my crop only because I haven't done a background extraction, and that messes with the color calibration. So I will crop this. And now I want to go to color calibration, photometric calibration. And you will see right here, it's using the local catalog. It's not going out to the web to find the star. And why this is important is speed. Again, speed. We already know that this is Bernard 33. I'm just going to change this to what I know it is. And I'm going to say, okay, and I want you to see how quickly it does the color calibration. So it's done. This is a huge improvement over going out to the web. And the advantage of doing it this way is that if you happen to have your computer out in the field someplace and there's definitely no internet, you could not do this stuff. So at least now you can take your laptop anywhere in the world, and as long as you have the local star catalogs, the astrometry.net plate solver, and StarNet++ local to your machine, you can do everything that Siril has to offer. So what I would like to show you now is star processing. So we're going to remove the stars. We're going to pre-stretch. And then just for the heck of it, what I want to show you is the, we'll do it this way first. So we'll execute this. This might take a little bit because the image is so big. And it tells you down here what's going on. So if you don't think anything's working, watch down in this area. And just as a reminder, this is 30 minutes of data. That's it. It's amazing how much you can get in 30 minutes. I don't think I mentioned it in my generalized hyperbolic stretch video that I did, that this was only 30 minutes. and it was terrible seeing. The moon was out. Seems like whenever I have clear skies anymore, the moon is up. Not good. But you can, like, this image is proof you can get decent data. Excuse me. So once this removes the stars, it will bring up the starless image. And we'll put the star mask into this working folder. Now, this computer that's doing this work is not the fastest one in the world. It's got a lot of cores. You can see it's got 16 cores, but the graphics card is a little weak in it. It's a T1000 NVIDIA graphics card, which isn't the most powerful one in the world, but it's still a graphics card. So I'm taking advantage of CUDA cores. Okay, we're almost done. Okay, so this is Cyril removing stars locally using StarNet++ command line version. And it's done a decent job. So what I can do now is go back to the star processing, go to star recomposition, and I will load the background, starless, and I will load the star mask. And now what you can do is you can work on these individually with the generalized hyperbolic stretch for each layer. So if I want to I'm just going to use the black point to knock the stars down a little bit. But you can see that it didn't affect the background layer. It did affect the star layer. So if you have any questions, you know where I live. This makes Cyril very portable, in my opinion. I'm also not a big fan of all this going to the internet uh, trend that seems to be going on. Someday the internet won't be there, boys and girls, and when that day comes, you're going to be screwed. So, again, you know where I live, and we'll see you in the group. Thanks.